Today we're going to continue our wireless section of the course with looking at Wi-Fi, which for most people it's the go-to wireless solution. Wi-Fi has become super popular over the last few years because of one thing, and that is the ESP8266. The ESP8266 is this little guy here, and it doesn't look like much, but it's actually crazy good value. They can be had for a couple of dollars, and while the module as a basic device isn't breadboard friendly, as you can see there are lots of other formats and boards that you can get. This is the original, and as I say, it came out a few years ago and took the internet by storm because it was so cheap and yet so powerful. Not only does it have Wi-Fi, the processor on here is about 10 times more powerful than what is on the Uno. And while the original only had 2 GPIO pins, 2 data pins, very quickly more versions came out, more capability was added, more pins, and more usable devices. So this little guy, super powerful. But if you already have a Uno, you don't need all those pins, and we can talk to it via serial, which is what we're going to do. Now, talking about the Uno, I do have to mention this, which is an ESP8266, but in the Uno form factor. And what is great about this is there are the pins down the side, just like on the Uno. You can plug into it, you don't have to use a breadboard, and it can accept a lot of Arduino shields, and you can program it using the Arduino IDE. But that's the ESP chip on there that you'll recognize. This is a Node MCU. It's got USB, it's got power management, and it's got the ESP8266. This is the big brother to the ESP8266, which is the ESP32. And the ESP32 is super cool because not only is it more powerful, it also has Bluetooth. And this is the Adafruit Feather version, the Huzzah, which is a really nice board, and you can run MicroPython on them. And this is the most premium version, which it comes with a screen and lots of other stuff like SD card reader, and it's like a stackable thing. It's called the M5 stack. It's the ESP32, and it's meant to be like an enclosed device with the buttons and the screen, and it's got a LiPo battery. So that's quite spendy, but for many people they don't need much more than what actually comes with it. And I think it has a Grove connector as well. But we're going to be looking at using the Arduino and the ESP8266 via serial. As I mentioned, it's not breadboard friendly. It's not breadboard friendly at all. So what I do is I use the male to female jumpers. So they go on there, and then you can plug into wherever you need to. An easy way people make a mistake with these is the pinouts. You need to understand which way up you need to be looking. So I always work with the chips on top and this gold aerial antenna to the left. Now it doesn't make it super easy because obviously you need to look where the pins are underneath, but it just means that everybody has an easy orientation, because with the gold to the left and the chips on top, you can't get it upside down. And they are very, very easy to fry. One of the big challenges with these is they only accept 3 volts, whereas all the pins on an Arduino Uno are 5 volt. But you can power it from the Arduino Uno. I've been able to use the 3.3 volt output of the Uno. They do suck down a lot of power though. It could theoretically be more current than the Uno can provide if you're doing a lot of things at the same time. So just keep that in mind and see if you have any problems. The other challenge is, because they've been around a while, there's various different versions, versions of the firmware, and while a lot of them use 9600 baud, like we've been using for serial, some of them come configured for 115200, but software serial isn't reliable at 115200, so we have to do a little playing around with some serial AT commands to set it to 9600 so that we can talk to it okay, and then after that should be alright. If you find that you are not able to source enough juice, enough current for it, then these little boards are really cheap, and they allow you to use 9 volt input and output 5 volts or 3 volts. And as you can see, on either side they go into the breadboard and they make the rails 5 volt or 3 volt depending on where the jumpers are. Just be very careful, look at the orientation of the plus and minus. If your breadboard was the other way around, then you'd be putting your ground wires into the power rail. So just make sure that you match up the red and the blue with the plus and the minus. You want the red on the plus and the blue on the minus. Don't get it the wrong way around. And then obviously make sure before you plug anything in that you've got the jumpers on 3 volts. This one's on 5 volts, but this one's on 3 volts. So it's got a little power button here as well, which is kind of neat. They're only cheap and they might save your ESP8266. So let's plug it into serial, and I'll show you a couple of tricks for making it work without needing much extra hardware. All you should use is your jumper cables, your Arduino and your USB. So like I said, with the antenna to the left, the gold antenna to the left, and the chips on the surface looking down on the chips, there's ground on the bottom left, and then there's the TX pin to the right of it. Above that is the second GPIO. Above that is a reset pin. To the left of that is the first GPIO. Above that is the RX. So the RX and TX are the serial connections. And then to the right of that is the power input, the VCC, plus 3 volts. 3.3 volts. On the Arduino side, first we're going to plug the RX to the RX and the TX to the TX. Ordinarily you would put the TX into the RX because you want to send from one device and receive on the other device, but in this first exercise we're going to use the Arduino Uno to pass through to the ESP8266. So we're just using the serial monitor to talk to the ESP8266 via the Uno. It'll all make sense in a second. On the Uno as well, you need to, as well as plugging in the 3.3 volts and the ground to the ESP8266, we also need to set the reset pin, and that will allow us to talk to the ESP8266. To prepare our Uno, we need to upload a blank sketch, and that will wipe it off and make sure that serial's not being used. So it's not going to do anything at all, it's just going to sit there not using serial. But that's very important because we need to make sure that the serial isn't being used while we go through this process. Now we can connect the RX and TX pins. Remember, we're doing TX to TX, RX to RX, because the Uno is basically just passing the serial through. And we need to plug the reset pin on the Uno to ground. Then we can open our serial monitor. Be very careful when you're plugging in the wires, just make sure that you get them all correct. Remember, looking at it from above with the antenna to the left and facing the chips, we're going to have the TX at the bottom right, we're going to have ground next to it. Above that we need chip enable, which needs to go to 3 volts. Above that we've got the 3 volt input, which is on the top right, and then to the left of that we've got the RX. And that allows us to use the serial monitor to talk to the ESP8266. And right now it's not particularly happy because I'm using the wrong baud rate. We need to change it to carriage return and new line, and mine come pre-configured at 15200, and we need to set it to 9600. To see if it's communicating, we do AT and press enter, and it'll come back okay. So I can see this is running at 15200 baud. So to set it to 9600 so we can use software serial reliably, we need to put in a special AT command that sets its baud rate. Now, because there are different versions, you need to try this one first, and only if it errors, try the second command. Okay, so this has given us an error. So now we try the second command. Don't try the second command unless it errors with the first. Now let's see if it'll be happy with 9600. Okay, we're working at 9600. Now the next thing we can try is we can see if it can see our network. Now to connect to my network, I use a different AT command called CWJAP, and my Wi-Fi, and then obviously I'm not going to show this, but my password. Then press enter and it should go away and connect. So now I should be able to get my IP address. By doing AT+CIFSR. And now I've got my IP address, so I'm connected to the internet. We'll leave it there for tonight, and then we'll get back tomorrow with an example that makes it easier to do the console, and then we'll do an example of using ThingSpeak. If we remember ThingSpeak from before, we'll send some data to that service and we'll see that it's logging that data.